The last risk I'd like to look at in this module is cross-site request forgery, otherwise known as CSRF. You may sometimes also see it referred to as XSRF. It's the same thing, just different acronyms. Now, OWASP also refers to CSRF in their top 10. It's getting towards the end, it's down there at number 8, but it is still serious enough to make the cut. Now, a bunch of these risk ratings are pretty much middle of the range. Average exploitability, common prevalence, and moderate impact. It is, however, very easy to detect, and as I said earlier, easy detection means it's easy for attackers to find. And as we'll see here in the description, CSRF simply takes advantage of the fact that most web apps allow attackers to predict all the details of a particular action. And really what we're saying here is that if an attacker knows what a request pattern should look like, and I'll give you an example of that in just a moment, they can trick the user's browser into making that request on their behalf. Now, in case that sounds a little bit odd, let's go and do a demo, and I'll show you exactly how that works. So back on our vulnerable site, and you'll see from the navigation bar, I am logged in. And CSRF attacks normally take advantage of the fact that the victim is authenticated. Because what the attack is going to try and get them to do is perform an action that only they can do. Let me show you what I mean. I've just received a link from someone. I'm going to paste it up here into the address bar. Now, hypothetically, I've been sent this link and told that if I go there, I will win some stuff. Now, normally the domain is a little bit more innocent looking than evilcyberhacker.com, but the point is that a CSRF attack begins with nothing more than the victim loading a resource on the attacker's website. They may not even explicitly be going to it by following a link. It could actually be loaded as part of another page they visit. So for example, the attacker's CSRF page could be loaded in a hidden iframe on another site. Let's see what happens though. I'm going to load this page. And this all looks innocuous enough. The check is in the mail. I must have won stuff. Something is going to come to me. But something else happened when we went to this page, and I want to show you what it is. I'm going to hit F12 to open the developer tools, and we're already on the network tab. Now here's what I want to do. Let me go and reload this page and we'll take a look at the requests that are made. So here we go, a bunch of them are just popped up down the bottom. I'm going to scroll all the way to the top, and I'm particularly interested in the first two. So the top one is the page that we just requested here. So /win stuff on evilcyberhacker.com. Number 2 is the really interesting one, because the domain that you see there is hackyourselffirst.troyhunt.com. It is a post request and it's going to change password. Let's drill down on that request and see what's actually happening. So here we can see the full path, /account/change password. There's the request method, it's a post. And if we scroll all the way to the bottom here, we see our form data. And the form data is sending 2 fields, new password and confirm password. And they're both set to hacker with an @ instead of an A and a 3 instead of an E. Now this is the form data that is required to set a new password. And what this attack has done is effectively replicated what a legitimate change password request looks like. Now the reason why this has worked is evident if we scroll up just a little bit. And what you'll see here is our auth cookie. So remember, the auth cookie is the thing that keeps us authenticated as we make requests across the site. I talk about the auth cookie extensively in the Ethical Hacking Session Hijacking course, because stealing auth cookies is what that course is all about. The problem is that the browser automatically sends this cookie simply because it is valid for the domain of the request. That's how cookies work. The upside for the attacker is that they can exploit that implementation by tricking the browser into making a request. Which begs the question, how did this page trick my browser into making the request? Let's have a look. I'm going to press Ctrl-U to view source, and here's what the page looks like. Now this is actually really simple. There's a form here, and the action of that form is that change password path. Now it's going to post, we can see the method there, and when it posts, it's going to target hidden frame, which is further down on line 12. And hidden frame is just an iframe that has no display. So it's functional, but you won't actually see it in the browser. The really important part of this page, though, is the two hidden input fields on line 9 and 10. And these are simply input fields that replicate the legitimate fields on the change password page. And that page requires a new password and a confirm password. Doesn't matter that they're hidden forms, they still get sent in the HTTP request exactly the same way. The final piece that ties all of this together can be seen on line 6 on the body tag, and it simply says that when the body loads, submit the form. So what ends up happening is someone merely goes to this page, and as soon as that page loads in the browser, the form is automatically submitted. Now, if that person is logged on and has a valid auth token cookie, this attack works. Their password is now hacker. So what that means is that the attacker now knows the user's password, and they could then go on there and do whatever they like with the account, including then changing the password to something else altogether. The reason this works is because the form we see here simply replicates a legitimate form. The request that occurs when this page loads is identical to the request from the change password page. Predictability is the problem here, and the solution is randomness. Now, randomness, in terms of protecting against CSRF, is achieved by using an anti-forgery token. And I talk about anti-forgery tokens extensively in my Hack Yourself First course. So if you want to understand more about the defense of a CSRF attack, go and check out that course and you'll see exactly how it works. So that's CSRF. It's an enormously powerful attack that takes advantage of the client. That's the last attack involving the client that I want to look at. Let's now move on and summarize the module.